Okay, so this is my test 2 corrections video. This is number 9. This is a problem that I honestly, I think I was a little confused about this theta value. I didn't really understand the polar functions really well. So this actually makes a lot more sense now that I'm like redoing it. So basically they're asking you to find the slope of the tangent line, and they give you r equals 2 over theta and theta equals pi over 6. So the first thing that I do is plug this pi over 6 into the theta value. Then I get 12 over pi because I just simplified this down. And then here, so I just rewrote the r theta equals 2 over pi again. And then I took the derivative of the 2 over theta, which is right here. And then I plugged in the pi over 6 back into it. And at the end, I get negative 72 over pi squared. And then that's the slope of the tangent line. Didn't find the equation because it's just asking for the slope. So the second question that I'm going to go over is number 8. This one's another polar question, so I guess I was having kind of issues with the polar problems, but this makes a lot more sense to me now. It says find the area of the smaller inner loop. So I mean, my picture's not that good, but they're asking you basically to find the area of this little loop right there. And they give you r equals 1 plus 2 cosine theta, and then it's telling you that it's from the points from 0 to 2 pi. So the first thing that I did was set 1 plus 2 cosine theta to 0. And then I find the values that lie in between the 0 to 2 theta, or 2 pi, sorry. And it equals, or it'll be 2 pi over 3 and then 4 pi over 3. So I know that those are my my bounds. So at that point, I know that the area function is basically like a simple integral. So basically I put in the 4 pi over 3 and then 2 pi over 3 for the bound, and then I plug the equation that's up here into there. Then I do the 1/2, that's part of the equation, and then d theta, which is the integral. So basically here I am basically just kind of separating this out. So since this is squared here, I just added the 4 plus cosine theta just to make it a little easier for me. I bring the 1/2 out of here because it's a constant, and I just keep simplifying through all the way. Here I just basically showed basically every single solving step that I did, just so that I made sure that I don't make any mistakes. Here at the end, we finally solved. So it was 4 pi over 3 and then 2 pi over 3. And I basically just plugged in the 4 pi over 3, and then I multiplied that by the constant that was on the outside. So here I did that on this side for the 4 pi over 3, right here actually. And then over here I have the 2 pi over 3, which I'm subtracting. Then at the very, so basically I reduced that into this little one, and then I kind of just took that in half, and what I was left with was negative 3 root 3 over 2, and that's what I got for that problem. And I'm pretty sure on my exam I had written out this huge this huge thing, and it was not supposed to be like that. I don't know how I basically did that. I think I was just a little confused on the problem. I didn't know how to get the bounds, so I don't think I did the bounds properly whenever I was taking the test, which is why I got it wrong, obviously. So this was one of the harder problems for me on the test, and I'm glad that I went through it, because this answer makes a lot more sense, especially since this is asking just for the area of the inner loop. I would say on the test that those were my 2 biggest issues, this problem and then this problem. But like I said, like the polar curves for me were just they were a little harder for me. But I worked through it. I kind of understand it a little bit better now, which is a lot better, which is better for me. So I guess for next time, I just need to make sure that, that I actually go through every single unit and make sure that I study for everything, just so that I don't miss anything on the test for the next one. But, okay, I think I'm done. Thank you.